Let's get right into it. If you were to ask someone what humanity will leave behind, they'd probably talk about the pyramids, or maybe the Great Wall of China, or some very serious-looking bronze statues of guys on horses. And sure, those things are neat. They're impressive feats of engineering and art, but they're also kind of boring. They're the expected answer. They are the carefully curated selfies we're trying to leave for future civilizations. But our real legacy, the thing that will truly define our era for whatever comes next, it's not going to be the stuff we put in a museum. It's the stuff we threw in the trash. It's the accidental, bizarre, and sometimes horrifying evidence of our brief, chaotic, and frankly, very weird time on this planet. Our real legacy is the cosmic mess we're leaving behind for the universe to trip over. These aren't the monuments we intended to build, but they're the ones that are going to last the longest. On Camilo Beach, on the southern tip of Hawaii's Big Island, the sand isn't just sand. For decades, ocean currents have been turning this remote stretch of coastline into a dumping ground for the Pacific Ocean's garbage. It's been nicknamed Plastic Beach, and for a good reason. It's less a tropical paradise and more a graveyard for everything from fishing nets to toothbrushes. But in 2006, a sea captain named Charles Moore noticed something new mixed in with all the debris. Something that wasn't just lying on the sand, but was part of it. They looked like multicolored rocks, but they were strangely light. He had discovered what geologists now call plastiglomerate. And it's exactly what it sounds like, a horrifying fusion of plastic and rock. You see, visitors and locals would often build campfires on the beach. In the process, all the microscopic and not so microscopic pieces of plastic junk littering the sand would melt down into a sort of primordial, technicolor ooze. This molten plastic would then act as a glue, binding together with natural materials like sand, lava rock, seashells, and wood fragments. When it cooled, it hardened into a brand new type of stone, a man-made rock, a fossil of the future created in the present. This isn't just happening in Hawaii. Plastiglomerate has since been found on coastlines all over the world. It's the Earth's crust actively, physically incorporating our garbage into its structure. Think about that. We have created a new material that is now officially part of the rock record. When future geologists, whether they're human or some kind of highly intelligent, six-legged crab person, dig through the strata of our time, they won't just find soil and stone. They'll find these ugly, immortal chunks of what used to be a bottle cap, a toy soldier, and a disposable lighter, all cemented together with a piece of a seashell. We spent millennia building monuments out of marble and granite, hoping they would last forever as a testament to our greatness. But it turns out our most enduring monument might be a lumpy, rainbow-colored rock made of melted-down Legos. It's our civilization's true, unintentional tombstone, and it tells a far more honest story than any statue ever could. We were here, we made a lot of stuff, and we were really, really bad at cleaning up after ourselves. How do you write a keep out sign that needs to last for 100,000 years? Now, how do you write it so that it can be understood by a civilization that doesn't speak any of our languages, recognize any of our symbols, and might not even be human? That's not a hypothetical brain teaser. It's a very real problem that some of the smartest people in the world have been trying to solve for decades. And the reason is buried deep under the bedrock of Finland. The place is called Onkalo, and it's a masterpiece of engineering. It's a massive, spiraling tunnel that descends nearly 500 meters into the earth, a tomb designed to hold Finland's high-level nuclear waste. This stuff is so unbelievably dangerous that it needs to be isolated from the biosphere for at least 100,000 years, roughly 20 times the length of all recorded human history. The engineering to keep the containers safe for that long is one thing, but the real challenge is what's called nuclear semiotics. How do you tell the future, do not dig here, ever? Think about it. The Christian cross is 2,000 years old and its meaning has shifted. The skull and crossbones can mean poison, pirates, or heavy metal band, depending on the context. Any symbol we create today could be interpreted as a marker for treasure, a holy site, or a king's tomb a few millennia from now. So a team of scientists, linguists, and even artists was assembled to brainstorm a solution. The proposals were mind-bending. One idea was to create a hostile landscape. They suggested surrounding the site with giant, menacing earthwork spikes and jagged, black concrete thorns that would make the area physically difficult and unpleasant to approach. The landscape itself would scream, "Get out." Another idea was to genetically engineer a species of cat, the ray cat, that would change color in the presence of radiation. The hope was that the cats would become living warning signs, passed down through folklore. If you see a cat that glows, run away. Seriously, someone got paid to suggest that. The leading proposal, however, is a message, but it's a message delivered with overwhelming, brutalist redundancy. The plan is to carve warnings into the rock walls of a chamber deep inside the facility. These warnings would be repeated in every major language on Earth, plus ancient ones like Sumerian and Sanskrit. But knowing languages die, they would also include diagrams of the human face showing expressions of horror and sickness, astronomical charts showing the decay rate of the radioactive elements, and basic scientific diagrams showing what an atom is and why this specific kind is bad. The idea is to create a Rosetta Stone of pure dread, hoping that at least one part of the message gets through. Our legacy here isn't just the radioactive material we buried, it's the philosophical crisis it created. We have produced a poison so long-lasting that we can't even trust our own species to remember what it is or where we put it. The last thing humanity might leave behind in this one spot is a desperate, multi-thousand-year scream into the darkness, hoping something, anything, is still around to listen. Have you ever been scrolling through social media and seen a birthday notification for a friend who passed away years ago? It's a uniquely modern and unsettling experience. A digital ghost, a phantom echo in the machine, reminding you of a person who is no longer there. Their profile exists in a strange limbo, frozen in time, a collection of photos, old posts, and inside jokes that have outlived their creator. Now multiply that experience by a few billion. This is our digital afterlife, and it's one of the weirdest things we'll ever leave behind. Every single day, humanity collectively pumps an astronomical amount of data into the cloud. Selfies, food pictures, terrible political takes, rambling videos, heartfelt messages, and an endless ocean of memes. This data lives on servers in vast climate-controlled warehouses all over the world. As long as those servers have power and their hard drives don't fail, that data just stays there. Think about the Library of Alexandria, a place that held the accumulated knowledge of the ancient world on fragile papyrus scrolls. Its destruction was one of history's greatest tragedies. Our modern equivalent isn't one library, but a distributed global network of information. And while a single server farm is vulnerable, the whole system is remarkably resilient. Organizations like the Internet Archive are actively trying to save a copy of everything, every web page, every public post, every digital artifact. They're building a library of our entire civilization. And they're not just saving the scholarly articles, they're saving the comments section. So what happens in 10,000 years when some future intelligence stumbles upon one of these data caches? They won't find the carefully curated letters of great thinkers. They'll find your awkward high school photos. They'll find your cringy relationship post from 2012. They'll find flame wars about whether a hot dog is a sandwich. They will have a perfectly preserved, searchable, high-fidelity record of our collective, unfiltered consciousness. It is by far the most detailed and intimate record of a civilization's daily life that has ever existed. And it is profoundly weird. They will learn more about us from the comment section of a cat video than from the ruins of our monuments. They might conclude we worshipped a pantheon of gods named Grumpy Cat, Doge, and Salt Bay. We worry about leaving behind statues and epic poems, but our real lasting legacy is a digital ghost, a detailed, embarrassing, and hilarious chronicle of everything, proving that the dominant feature of our civilization was glorious, unapologetic nonsense. Geologists have a cool, if slightly dramatic way of marking time. They look for what's called a golden spike, a clear physical line in the rock layers that signals a major planet-wide shift. The end of the dinosaurs, for example, is marked by a thin global layer of iridium deposited by the asteroid that wiped them out. It's the Earth's way of saying, and that's the end of that chapter. So what's the golden spike for our era, the so-called Anthropocene? Is it the carbon from our industries? The radioactive particles from atomic tests? According to some scientists, it's none of those. It's chicken bones. No, seriously. The most telling, globally identifiable fossil of the human age might just be the remains of a bucket of KFC. Here's why. Before the 1950s, chickens were just birds. They were varied, they grew slowly, and they weren't all that common. But then came the rise of industrial agriculture and the invention of the modern broiler chicken. Through intensive selective breeding, we engineered a new kind of animal. This bird is a biological marvel of efficiency. It grows to full size in just 6 weeks, develops massive breast and leg muscles, and is so genetically uniform you can barely tell one from another. It is, biologically speaking, a completely different creature from its ancestors a century ago. And we have made a lot of them. Right now, there are over 25 billion chickens alive on Earth at any given moment. That's more than 3 chickens for every human. We slaughter over 70 billion of them every single year. After we're done with them, their bones, which are distinct from any chicken bone that came before, are thrown into landfills all across the planet. Since these bones are often buried in the oxygen-free environment of a garbage dump, they don't decompose. They fossilize. The result is that we are creating a clear, dense, and globally distributed layer of chicken fossils that will be easily identifiable in the geological record. Forget the age of mammals or the age of reptiles. Any paleontologist digging down millions of years from now will hit a certain point in the rock strata and suddenly find a planetary-wide explosion of broiler chicken skeletons. They will have no choice but to name our time the Galacene Epoch, or perhaps the Great Chicken Event. This is our real legacy, not a monument to our intelligence or our artistry, but a fossil record that says the single most significant thing we did was get really, really good at making chicken nuggets. In 1907, NASA was getting ready to launch 2 of the most ambitious space probes ever conceived, Voyager 1 and Voyager 2. Their mission was to take a grand tour of the outer solar system, but everyone knew that after they flew past Jupiter, Saturn, Uranus, and Neptune, they would just keep going. They would drift out of our solar system and into the vast empty expanse of interstellar space, potentially for billions of years. So a small committee led by the astronomer Carl Sagan was tasked with an absurdly beautiful and impossible job: create a greeting card for the entire human race. The result was the Voyager Golden Record, a 12-inch gold-plated copper phonograph record that is arguably the most optimistic and poignant object humanity has ever created. The challenge was immense. How do you summarize all of human existence, our science, our art, our biology, our feelings, on a disc for an alien species that has no concept of what a human or a record player even is? The team included instructions on the record's cover, a sort of IKEA manual for aliens, showing them how to build a stylus and play the record using universal scientific constants. And what's on the record itself? It's the ultimate mixtape. It opens with 115 images, encoded as audio signals, showing everything from the structure of DNA to a diagram of a man and a woman, which caused a bit of a stir at NASA at the time. Photos of cities, forests, and a person eating. Then come the sounds. There's the sound of wind, rain, and surf, the cry of a baby, the sound of a kiss, and the brainwaves of a woman in love. There are greetings in 55 different languages, starting with Akkadian, a language spoken 6,000 years ago, and ending with modern Chinese dialects. And then there's the music. The team wanted to capture the breadth of human culture, so they included everything from Bach and Beethoven to folk music from around the world. And in a moment of pure rock and roll optimism, they included Chuck Berry's Johnny B. Good. The story goes that when someone questioned this, Sagan replied, "They'll just have to deal with it." Voyager 1 is now over 15 billion miles away, the most distant human-made object in existence. The odds that any civilization will ever find this tiny message in a cosmic ocean are vanishingly small. But in the end, the real audience for the Golden Record wasn't some distant alien race. It was us. The process of making it forced us to decide what part of ourselves was worth preserving. It's a symbol not of what we are, but of what we hope to be. A lonely, lovely song floating in the dark. What is the single most durable, long-lasting structure humanity has ever built? Your mind probably goes to the Great Pyramids of Giza or some top-secret underground doomsday vault. Solid guesses, but you're thinking too small and too close to the ground. The most enduring thing we've ever made is currently circling the globe 3,600 miles above our heads, and it's about the size of a large grapefruit. It's a satellite called Lagios 1. Launched by NASA in 1976, its name stands for Laser Geodynamics Satellite, which is a very dry, scientific way of saying space cannonball. Unlike most satellites, Lagios has no electronics, no moving parts, and no internal power source. It is essentially a solid brass sphere with an aluminum coating weighing about 900 pounds. Its surface is studded with 426 special prisms, called corner cube retroreflectors. Its entire job is to be an extremely passive and extremely good target. Scientists on the ground shoot powerful laser beams at it, and the retroreflectors bounce the light directly back to the source. By precisely timing this cosmic game of catch, researchers can measure the movement of Earth's tectonic plates, the wobble of its axis, and the subtle variations in its gravitational field. But here's the legacy part. Because Lagios is incredibly dense and was placed in an exceptionally high and stable orbit, it is barely affected by atmospheric drag. It is predicted to remain in orbit for an estimated 8.4 million years. Let that sink in. This little metal ball will outlive every single thing on the surface of the Earth. The pyramids will erode into dust. The continents themselves will drift and reshape into unrecognizable forms. Entire mountain ranges will rise and fall. Ice ages will come and go, and this tiny, man-made moon will silently keep watch over it all. It is the ultimate passive observer. When it finally does deorbit and burn up in the atmosphere, 8.4 million years from now, the world it returns to will be more alien than the one we can imagine. And in a classic Carl Sagan move, he designed a small plaque placed inside the satellite. It's a simple message for whatever intelligence might find it, showing the arrangement of Earth's continents in 3 panels. The past, 268 million years ago, the present, and the predicted future in 8.4 million years, right around the time the satellite is expected to return. It's not a mixtape of our culture, it's a quiet, scientific note that says, simply, we were here, we measured things. For about 4 billion years, life on Earth has evolved according to one set of rules: natural selection, random mutation and environmental pressure, slowly, painstakingly shaping every living thing. And then, in the late 20th century, a species of clever, upright apes figured out how to get into the source code. That's us. And our edits are going to be one of the most permanent things we leave behind. This isn't about the rock we leave in the ground or the junk we leave in orbit. This legacy is alive. It's called genetic engineering, and it's our signature written directly into the DNA of other living organisms. We aren't just building things anymore. We're rewriting things. Take the glowfish. It's a very real pet you can buy right now. Scientists took a regular little zebra daniofish and inserted a gene from a fluorescent jellyfish or a sea anemone. The result? A fish that glows with a brilliant neon color under a black light. It's a living work of art, a biological novelty item. And now that they exist, they're in the ecosystem. People buy them, people sometimes release them, they breed. 1,000 years from now, a new species of fluorescent fish could be a common sight in the waterways of North America. Future ichthyologists might be completely baffled, wondering how this one family of fish developed a biological trait that has no evolutionary advantage and is chemically identical to a protein found in a deep-sea invertebrate. The answer? Some dude in 2003 thought it would look cool in his aquarium. It doesn't stop at glowing fish. We have the Aqua Advantage salmon, engineered to grow twice as fast as normal. We have crops like BT corn, which have a gene from a soil bacterium that produces a natural insecticide. We are creating organisms that could never have existed in nature, weaving the tree of life together in ways evolution never intended. If our civilization were to vanish tomorrow, these creations wouldn't just disappear. They would continue to live, compete, and pass on their modified genes. Our legacy wouldn't just be found by future geologists or astronomers, but by future biologists. They would find our fingerprints all over the planet's biosphere. It's the ultimate form of graffiti. We didn't just paint on the walls, we hacked the operating system of life itself, and that edit could be copied and passed down for millions of years. Imagine for a moment the sound of the universe. For billions of years, it was nothing but the quiet hum of stars, the silent dance of galaxies, and the occasional boom of a supernova. And then, around the year 1900, on a tiny, watery planet in an unexceptional corner of the Milky Way, something changed. The planet started to make noise. This is our radio bubble, and it might be the most ephemeral yet widespread legacy we have. Ever since the first powerful radio transmissions, we have been unintentionally shouting into the cosmos. Every radio show, every television broadcast, every radar pulse, all of it has been leaking past our atmosphere and traveling outwards in all directions at the speed of light. Right now, we are sitting inside a sphere of our own creation that is more than 200 light years across. This sphere is a perfect expanding time capsule of our modern history. At its very leading edge, now 120-odd light years away, are the faint, crackling broadcasts from the 1920s and 30s. A little further in, you'd find the first television signals, broadcasting grainy images of sitcoms and news reports from the 50s. Closer still are the powerful military radar pulses of the Cold War, a sign of a species both brilliant and terrified. Any alien civilization within that bubble with a sensitive enough radio telescope could be listening to our history unfold. They could be receiving the broadcast of the 1936 Berlin Olympics right now. But the most profound part of this legacy isn't the noise itself, but its eventual end. At some point, this bubble will likely stop expanding, either because our civilization collapses, or more optimistically, because we transition to technologies like fiber optics and focused transmissions that don't leak into space. The shouting will stop. The sphere will become a shell, its outer edge continuing to expand across the galaxy, but its inner edge defined by the moment we went quiet. The last thing we say to the universe won't be a carefully chosen message like the golden record. It'll be whatever happened to be on TV or the radio at the time. An advertisement for a soft drink, a reality TV show, a pop song. That final accidental broadcast will continue its journey across the cosmos for millions of years, an ever fainter, ever expanding echo of who we were. Our ultimate legacy may be the noise we made, followed by a profound and final silence. So there you have it. Our real legacy isn't the monuments we plan, but the weird, accidental, and sometimes beautiful mess we leave behind. If you want to explore what other strange footprints humanity is leaving on the universe, make sure you're subscribed for the next one.